Linh-chan and Dimi-chan, write code. So we're going to check the file exists. What am I not getting? Exists.
What is FM?
So FM is our file manager.
Oh, okay.
And our file manager basically gives us access to all the files on the system. And we want to make sure that if there is a file at the output path, we want to be able to get rid of it. So that way we can override it with a new render. So if there is a file at path, file exists at path, hopefully it will wake up soon. I'll put url.path. I don't know why you can't check for file existence with URLs in NSFileHandler, but you need to use a path. And then in this case, we will check if it was, we'll say file manager, and we'll remove it. That way we can put a new file there. .path, and then if there's an error removing it, let's capture that error. And if there's an error, success will now be no, which means that we won't get to the next part of using that file. So if success, we will set success to depend on if we can set up our asset reader. So we'll do that later. And then we'll yet again success. We'll set success to depend on if we can set up our AVAssetWriter and start it. AVAssetWriter. And then if we're not successful, then we can show the error and get out, basically. So if we're not successful, we will call helper method, which let's make it right now. Void. So we'll say reading and writing, reading and writing did finish successfully. So if you didn't think you'd be a writer as a programmer, you're going to end up writing a lot. So if you hate writing, maybe programming is not for you. Here, I have line numbers hidden because Xcode thinks they're not necessary. And honestly, I never refer to them anyway, so I just left them off. But on all my other computers, are all on. And on my reference page behind me, it says 483 lines. So that's how much we will have written by the end of this. So we want to capture that error if there is one. And then basically now we can see if we're not successful, we can cancel all our progress that we were doing. So AVAssetReader, cancel reading, AVAssetWriter. So basically clean up. So if you were using this as a general transcoder, you can reuse all the pieces here. In this case, we won't, but it's always good practice to clean up. If there were audio settings that we set up, we didn't set them up yet, but if there were any and we failed, we can go ahead and log these. So that way we can see what happened. Failed audio settings. And then we'll go ahead and print these. I like putting an extra new line in there because it is a dictionary. Audio setting. Settings, there we go. So that lets you change all instances of that variable, so that way you can rename them all. Video setting, so I screwed that one up too. Settings, video settings, failed video settings, and then if we didn't fail, we'll just say that we finished, or that we'll reset it so that way, again, if we want to reuse this, we can. So we're not finished anymore, even though we were. So audio settings, audio finish, I mean, no. And then we'll go ahead and reset everything. So asset reader equals nil. So if you're using Swift, these would all be optionals. In Objective-C, everything that's an object is an optional since they're all pointers. But yeah, if you're translating it, it's a good thing to know. Asset reader audio output equals nil. Asset reader video output equals nil. Asset writer audio input. I need to rename that.
That's it.
So we can go there, hit it on scope, input, and there we go. Where was that? And then asset writer video input. I don't think it exists. Output. Someone type it for me. And then I'll go and click on our magic little triangle and say this is input.
If it doesn't exist, how can you change it now?
The output existed. Like when it said output, it did exist. So I was able to change the output to be input. And now input exists because I changed it everywhere. That's what that little triangle did. It changes it in the whole context.
Oh, so you don't need to go find where that part is and then change it?
Exactly.
Okay.
So it's very convenient for that. And then finally, when we finish, we'll say that our progress is equal to 1. And we shouldn't do that right there. We should do that on our main queue. So we'll asynchronously dispatch to our main queue because we're not necessarily on our main queue. Dispatch get main queue. There we go. So here we want to make sure that we are on our main queue, which is where all the user interface updates go. So since we are changing the user interface indirectly by changing these properties, we want to make sure we're on that main queue so that way nothing funky happens. So we'll go ahead and set the status text to if we are successful. So if this argument is true, then we're going to say one thing. So in a string with format is our friend, and we're going to say completed encoding or resizing. Let's be a little more human about it. What on earth is encoding? And then we'll put the file name and put a period because we're done. So self.path dot last path component, which it does not know exists. One day it will know. And if we failed, we will go and make another string. So, string with format. Okay, I think it just gave up on me.
You're overworking my computer.
This is an 8-year-old computer, mind you. And it's doing quite well. It's running the latest version of Xcode. It's not blowing up. The only thing it can't do is encode video. So that's why I have a 1-second video. That's our test footage that we're going to see and make sure this all works with. Self.path.lastPath component. Okay. So this should get the status text. Now we want to say for finished equals yes, because we're finished. So let's basically hide that progress bar. And now let's inform our delegate. Self.delegate job did complete job self. So we are the job, so we need to tell the delegate which one did. And then if there was an error, we'll pass the error right here. You should never call protocol method on the delegate directly. So this is part of our job delegate, but we don't know if our delegate did it because this is not required. So the safer way to do this in Objective-C, I believe it's slightly different in Swift. Like Swift can verify things to be required to prevent these kind of mistakes. So if it is required, we can go ahead and do that in Swift directly. But in Objective-C, you do need to go self.delegate response to selector and then specify the selector and say that it's the job did complete with error selector, and then put that on brackets and all in an if statement, and then actually call it. Otherwise it will crash, because although this can be nil and you can call anything on nil, if this is not nil and you call something on something that doesn't have it, it will crash. So this is definitely much safer. So I'm improving on the code I originally wrote. I was lazy. So since we wrote our nice ending call, we can go ahead and say self reading and writing did finish successfully. No, with this error that we got back. And that's basically going to coordinate everything. Now we want to actually start setting everything up. Oh, sorry, taking a swallow.
More water.
No, I'm good. So we want to set up our asset reader so we can actually start doing something. So let's go ahead and make a new method. It's going to return a bool. So this is going to be used right here. So let's actually comment that out so we don't have issues. This is going to be used in this first step right here, where we set up the asset reader. So we're going to say set up asset reader and asset writer 1T. We'll get that eventually. And we'll specify that we can push out an error if we need to. In Objective-C, when you want an in-out variable, you have to pass it by reference. So you put 2 stars. In Swift, you just write in-out, I believe. Out error. And here is where we're going to be doing most of the work. So let's go ahead and uncomment this. We can use our new fancy method. Self set up asset reset and writer, and we'll pass our error. And we'll pass our error. And we'll be sure to pass everything by reference. No, that one doesn't need reference. Water tastes so good sometimes.
All the time.
All the time. Yeah, sometimes it's a little plain and boring. But we already spoke at length about water. Did we even speak?
We mentioned it.
Yeah, we mentioned it
in one of our other videos.
Check out our other videos. We do like a general podcast type thing over a Let's Play. So that should be fun to watch. We're trying to keep on the more serious angle, so you can actually learn new things rather than laugh at jokes.
Stupid jokes.
Fart jokes. Reader. The App Store is a big fart joke. Just kidding. Actually, Apple does not allow fart apps into the App Store anymore. They said there are too many. So they, in their review guidelines, they're like, do not write another fart app unless you have something valuable to add, which means nothing. So we're going to make a new asset reader with our asset. And if there is a problem, we will use our out error. So we're just going to keep using that error that was specified. And we're going to set up a new success variable to know if we're doing stuff correctly. Success equals
asset.
Totally not an asterisk. Does not equal nil. So we want to make sure we have an asset reader. If we don't, bail. You get the drill. Now, if we do, success. There we go. We want to make a asset reader. So let's make our asset writer, I mean. So let's make our asset writer. So it's going to be AVAssetWriter. Okay. And with URL. So here we're going to be specifying the output URL. Output URL that we made the first time around. So this is where the file is going to end up being written. And then we're going to specify what type we want. So file type QuickTime movie, general purpose movie, output error. Output error. No, there we go. Blah, blah. So we're going to capture the error from that if there is one. We're going to specify that we want our writer to be optimized for network use. So if it is streaming in any way, we want it to be in order and not have to download the whole file before you know, hey, there's a video thing in here, which could suck on a network. And then we're going to check if we have an asset writer. If we don't, that means something horribly wrong went on, and we can bail early. Does not equal nil. So now we'll check again if we're still successful. If we're not, that means we bailed early. And let's set up our audio output and input. So let's get our audio tracks, NSArray audio tracks. So I'm not too sure what happens when you have like a crazy amount of tracks. I've only tested this on simple video files, so I'd be curious to know if anyone tries it. Tracks with media type, AV media type, so we want only the audio tracks. So a media file is essentially a collection of tracks. So you can have audio tracks, that's the sound you hear. Video tracks, that's what you see. You can have multiple video tracks. On like some DVDs, there was an angle button that you can press, and that will give you a different angle of the action. That's essentially a different video track. Same with the audio. If you have different languages, you have multiple audio tracks for all of that. And then you can have text tracks, subtitle tracks, metadata tracks, all sorts of tracks. So we just want the audio track. The story had gone short for the time being because we want to process that. And all other non-audio and video tracks will be left out of this transcoding. So we're not going to maintain everything. We're just going to maintain what we can actually do something with. So if we have some audio tracks, so you can either type it like this or like this. I prefer it honestly with the dot syntax because it's like a property. Okay, so if we have some audio tracks, then let's set up our AVAssetReader audio output to be of type AVAssetReader track output, and that's basically going to take the audio track as is and process it through. AVAssetReader track output with track. So we're only taking the first audio track. I imagine if there were multiple audio tracks, you'd have to set up multiple AVAssetReader audio outputs, each one for each track. That sounds more complicated than it needs to be for what I'm using this for. So I'm not going to be doing that. Output settings, we'll set them to nil and let it figure it out on its own. And we'll add this output to our AVAssetReader. So AVAssetReader add output AVAssetReader output. Yeah, there we go. So we'll add this AVAssetReader audio output to our AVAssetReader, so that way it knows to read that track and not the others, basically. And we'll do the opposite for the writer. AVAssetWriter audio input is going to equal AVAssetWriter input. And here we're going to specify that we're going to be writing audio objects. So since we're not dealing with audio in this app very much, we're mostly going to skip, I don't know what the difference between this is. We are mostly going to skip skip processing the audio, and we're just going to use it as is. So this is an easy way to do that. Audio tracks. So I imagine if there are other tracks, you can do something similar to get them all through. Media type. There you go. I imagine because I didn't specify what the audio tracks were, it doesn't know what to do. So if I specify AVAssetTrack, so here I'm specifying the track for the audio track, so that way I can use dot syntax and it knows what I'm dealing with. So we have no output settings that we care about. And just like we did for the reader, we're going to add this input to the writer. So writer add input asset writer audio input. Now we're going to do the same for the video tracks. So the audio tracks were set up. Let's make copy paste for video tracks, and now we're going to type video. And again, we're mostly interested in just the first video track. So if video tracks.count, we will go and basically do the same thing. So I do want to specify some settings, basically because the whole goal of this is to resize the video. So we do want to, like here we weren't using the audio settings that we set up, or is it here? We're not really using these because we're not changing the audio in any way, but we are changing the video. So I do want to set up video settings. So video settings is going to be a big dictionary, and we're going to specify all sorts of fun things in here, like the AV video codec key, and the codec is going to be H.264, AV video H.264. Next, we're going to specify the width, AV video width key, and we need a size for this. Let's specify that. So CG size, new size, and for now let's just say CG size make with 1920 by 1080. So we're going to be uprising it arbitrarily. We'll do something fancier afterwards. But for now, let's keep it simple. So the width is going to be a number. So new size.width. And then AV video height key is going to be new size.height. And then we want to specify the color primaries because I think you need to do that, otherwise it freaks out. Video color primaries key. And this itself is a dictionary, so we'll go in and we'll specify. So AV video. This is the part that if you get wrong, it just does not work and then it doesn't tell you why. Primaries key is going to be AV video ITU 7092. Primaries. Okay, and then AV, this one's a transfer function. And then AV transfer function 709. So ITU R709 is basically the HD standard. So HD specifying like 1080p is, it uses the 709 standard. SD uses the 602, I believe. It's gonna show up, I'm sure. But I need the matrix, video matrix key, and then AV matrix. So 601, that's standard definition video. So if before HD TVs, you'd have this standard instead, if you were curious. But now that we have that set up, we can say that, okay, that one's good, and then go back and specify the compression properties. So we do want to be able to specify like things like bitrate and all that jazz. So we're going to say AV video compression properties, and this itself is also a dictionary. The first one is going to be the average bitrate, and this is going to be in bits. So if we want 10 megabits per second, we need to have 10 million. So let's put 10, 1, 2, 3, 4, 5, 6. It's 10 million. And then if we want, we need to specify the profile as well. This video is, of course, simple. AV profile, level key, and then I think this is the last one. So AV H264 high auto level. So this is going to give us the best profile for the high one. If you want this to be more compatible, you might set it to a lower one, so you have a whole bunch of options here, like the main profile baseline for like cell phones and stuff from back in the day. High should work in most cases, especially if you're going to process it in something like iMovie afterwards. But yeah, this should work. Lynn's laughing because we're watching the watchers steadily go down as this gets more and more complex, which is completely fine. We plan on putting it on YouTube afterwards, so if this is getting a little bit over your head and you want to digest it a little more slowly, please. Like no need to feel like you're understanding it all in one go. But with all this information, we can start doing something fun. So we do need some separate decompression settings, of course. So let's make a dictionary, decompression video settings. And these are going to be very similar to the ones we just did, except they're going to contain some OpenGL information that's going to help the system know what to do with the frame buffers. So the first one is going to be called KCV, pixel buffer format, pixel buffer pixel format type key. There we go. It's a mouthful. And then we want KCV pixel format type, and then we want 422. This one. This is basically going to specify how we want the pixels to be arranged. 422 means we're going to split up the RGB signal into luminance and then difference in red and difference in blue, roughly. And the goal here is to store lots of luminance information and very little difference in red and difference in blue information. So that way the video can be small and still be viewable, since our eyes are most sensitive to green and not red and blue. So that's where the luminance comes in. We get the pixel buffer, and then the next one is going to be ID. So we do need to convert these to Objective-C objects, since we are using an Objective-C dictionary, and they are C. They're not C, they're C structs, but they're not like strictly C, they're kind of object-oriented. They're called C Core Foundation CF string. They are C structs, so they do need to be converted. IO surface properties. IO surface properties key. So this one just needs to be an empty dictionary for it to be happy, and then we need the width and the height, and then that's it. So CV OpenGL buffer, no, pixel buffer width. These are the things that if you get wrong, it will not be happy with you, and then it won't really tell you why. So it's good to take a moment to make sure that they're all set up correctly, and then once you kind of set them up, you don't really need to change them ever again. So that's kind of good. Height, and then make sure this one's the height. So that should set up that decompression dictionary, which means we can set up our AVAssetReader. Yay! So now we're going to do the same thing that we did for the audio. So we're going to get the AVAssetReader video output. And this is going to be AVAssetReader track output. There we go. AVAssetReader track output with track. So now we can get our video track. So video tracks dot first object. So we're just going to get that first video track. And we are going to pass in our decompression settings. So this is how we're basically specifying how we want the memory to be laid out for what's coming in from the file. And then we are going to add it to our AVAssetReader. AVAssetReader add output. And now we want the AVAssetWriter, which thankfully is much simpler. AVAssetWriter video input equals basically this. Let's copy. We're going to cheat. Okay, so we got the AVAssetWriter. This time we want the video track. Excuse me. Actually, we want AV media type video. So we're going to have an AVAssetWriter of type video, and the output settings are going to use our video settings that we set up instead of nothing. And then we're going to add this input to our AVAssetWriter, and then we're going to return if we're successful. Return success. Okay, so that sets up our AVAssetReader and writer, and now we actually have to do the conversion. So let's go ahead and close show editor, show blame line, code folding.
What are you doing?
I want to show the folding thing so I can get rid of it. I don't remember where it is. Okay, maybe it's whatever. This series was originally live streamed, so we split it up into 30-minute episodes so it can be uploaded. Since it does take more planning to make this kind of content, we don't plan on producing it very often, but if you do enjoy it, please subscribe on YouTube or Twitch and let us know in the comments below or on Twitter. Thanks! Bye, Chan-chans!